In this video, I want to go over how to evaluate regression models. We're going to use the regression option in the stats add-on for Google Sheets. And we're going to generate three different plots: residual plots, QQ, or what are also called quartile plots, and we're going to also have influence plots. So let's go ahead and go over here into the data. We're going to close this describe data option, and we're going to go to our. Let's first look at what we want to predict. And let's say we want to predict the number of alcoholic drinks per week based on extroversion. So we're going to go over here to statistics, regression. So the regression option, this is the first time we're using it, is very similar. Instead of the variable and by, it has response variable and predictor variables. So response variable is going to be extroversion. Excuse me, it's number of alcoholic drinks per week, so we'll click on that. Our predictor variable is extroversion. We're going to add our label, which is our person variable. And we're going to want to plot influence. We're going to add variable plots. We're going to uncheck residuals versus time. Again, we could filter it if we wanted to only examine a subset of the data. Let's go ahead and hit create. And so we get our overall fit statistics. We get our R squared out of this, and we also get our regression coefficients. Instead of just saying regression coefficients, now they're just labeled as coefficients. This is exactly similar as I've gone over in the previous video. We have a residual plot, and if basically what we're looking at with the residual plot is we're kind of looking at the trend of the data along this horizontal line right here. So if we look at the trend of the data, we generally see that it kind of is generally distributed in almost like a circle or a square around that. That's what we're looking for. If the data showed maybe a slight arcing trend, like it was denser up here and denser in these two areas, would maybe indicate that there was an additional trend in the data beyond the linear trend. But that's what this is evaluating. If we go ahead and look at our quartile plots, we can see that generally all of these blue dots fall along this purple line here. We see a couple points, and if we click on those points, we can identify which persons these are. They're kind of moving off this line, but overall this is pretty good. If you saw what we'd be looking for to indicate that the data was highly non-normal, we'd be looking for points that started to trail off very far from this line, like what I'm trying to represent here with these red dots. But we don't really see that. We see a little bit of that down here, but we're not too worried about that. And then influence plots. So we've talked about this concept of leverage. So leverage is the distance from the center of the data, and then Cook's distance is a measure of basically influence or how far away from the regression line. And basically, when we're looking at this, we're trying to look for kind of points that fall in this upper square up here are on the right of this purple line and above this orange dash line. And so if we look at this guy right here, person 29, is potentially of high influence because it has high leverage and is also high Cook's distance. We can see if any of these points correspond to 29. We don't really see. We can try to find person 29 in here. Overall, this data looks pretty good. So there's person 29. So he's pretty far away from the line here. It's kind of down here in this corner. And then the final plot we have is our add variable plot, which is basically the same as a scatter plot, but it's a little bit more difficult to interpret. So when we want to create our scatter plots, we want to actually use the described data. That's why I showed you that in the previous video. So These are some diagnostic plots that you can use. We're not going to go into this too in depth. Generally, it's good practice to always look at these diagnostic plots when you're performing regression in order to make sure that you're not violating any assumptions or any of the conditions under which you're performing regression. And that's how to do that.